Okay, today we are going to derive the natural log of x. Let's just write a little note here. And remember that ln x is the same exact thing as log base e of x, and that it equals y. Okay? Let's just make this little note. Okay, our first step is going to be to look at the inverse relationship of the natural log of x. So we know that log base e of x equals y, and I'm writing this the long way so that we can see the relationship better, is the same as e to the y equals x. And I think that everybody learned it this way probably. If you've never seen it before, then maybe this will be helpful, that you kind of just go counterclockwise, right? So you know that the base is going to be the base of the exponential expression, and you know that the on this side of the equation, the y or the x or whatever it is that's on this side of the equation is going to be the exponent, and that the argument of the log is going to switch sides, so to say. So now what we're going to do is we're actually going to use this expression, this way of expressing it, to derive the natural log of x. And we're going to differentiate both sides. We're going to do this using implicit differentiation, which is when you differentiate both sides with respect to x, and you end up with inverse functions here, you end up with a chain rule. So that makes it a little bit more complicated, but it's pretty straightforward mostly. We're going to derive e to the y with respect to x, and we're going to derive x with respect to x. And that's just going to be 1. Here is where the chain rule is hidden. It's going to become de to the y over dy. So we're actually going to derive e to the y with respect to y, and then multiply that by the inner function, which is going to be y. We're going to multiply that by y derived with respect to x, which we don't have yet. We're going to isolate, and then we're going to solve for that. This right here is actually going to be our slope of the tangent line. So it's very important. Okay, so the derivative of e to the power of y is just e to the power of y. We know that. So we're going to end up with dy over, I'm going to make this step 3, dy over dx is 1 over e to the power of y. And now we want to get rid of this y in our denominator. So we're just going to, I'm going to go up here to step 4. This is the solution. We're just going to remember that e to the power of y is x. And we're just going to substitute. So we find out that d over dx, which is the slope of the tangent line and is the same as d over dx of ln x. So differentiating y with respect to x is the same as differentiating the natural log of x with respect to x here, okay? And it equals 1 over x. That is our solution and our inverse formula.